Hello and welcome to Reill's tutorial. In today's video, we will continue with kinematics from the last session. Please like, comment, subscribe, and share. Thank you. Okay, now let's dive in. The last video, we talked about the kinematics and we talked about displacement, position, and distance time graph. But today, in this video, we'll focus more on speed and velocity, acceleration, and uniform acceleration motion, and the big five. Now let's dive in. First, what is speed? When we talk about speed, what are we considering? What are we talking about? What is the focus of speed? The word speed, we call speed. The speed is the total distance traveled per time travel. Total distance travel. Let's assume a journey starts from here, point 0, and move all the way to this distance, let's say 30 meters, like the last video. So the speed is calculating the total distance travel from the start point to the end point. The total distance travel here in this scenario is in meter. So the speed is calculating the total distance travel, the distance travel over the time. So if we have this distance travel in 13 meters and you spend 10 seconds, so the total distance travel will be the distance, the 13 meter over the 10 seconds. And the unit of speed is meters per second. So 30 meters over 10 seconds will give us 1.3. 30 meters over 10 seconds will be 1.3 meters per second. That will be the speed. This is the speed. By the time we calculate it, 500 divided by 78 seconds will yield a value that will be 6.4 meters per second. So that is for the average speed. The next one says, and the magnitude of her average velocity. So we're looking to look for the velocity, average velocity. Our average velocity is the change. Average velocity is the change in displacement over change in time, over change in time, which is equals to, now this displacement, the initial startup point is what? Started at the initial point at 0, that's 0 here. Then she ran and goes back to the origin, 0 minus 0 meters. Let me take that again. She ran from the origin and returned back to the origin. So the displacement, the start point was at 0.0 meters. That is the finish point. She went back to the finish start point at 0 meters minus 0 meters. So there was no change in displacement because she went back to the same start point over the time. Started at 0 seconds and ended at 78 seconds. That is 78. That is 78 seconds minus 0 seconds, which is equals to 0 over 78 seconds. 0 over 78 seconds. So the average velocity is equals to 0 meters per second. Because Displacement is the change in position. So that's why we have it as 0. But the average speed is the total speed, total distance. Velocity is the change in displacement. So let's always remember this key point, because these factors are factors that make students miss these questions in exam. Okay, now let's click. So now, what is acceleration? Acceleration is the change in velocity over time. Now let's go back to real life scenario. When you're driving your car and you step on the gas pedal on your car, the car speed increases. But when you step on the brake, the speed decreases. Then you turn the wheel, the car's direction of motion changes. In all of these cases, the velocity changes. To describe the change in velocity, we need a new term called acceleration. So in the same way that velocity measures the rate of change of an object's position, acceleration measures the rate of change of an object's velocity. So an object's average velocity is defined as the change in velocity over time. That is, velocity is denoted as A is equals to change in velocity over time, change in time. And the unit of velocity is meters per second square. Per second square. And the change in velocity is talks about the final velocity minus the initial velocity over same thing as change in time, the final time minus the initial time. So we always remember to note the velocity, the change in velocity, as the final velocity minus the initial velocity, the final time minus the initial time. And the unit is meters per second square. One thing you also wanted to note is that an object can accelerate even if the speed doesn't change. This is because the acceleration depends on a change in velocity and the velocity vector changes if the speed changes or the direction changes or both of them changes. For instance, a car traveling around a circular racetrack is constantly accelerating if the car's speed is constant, because the direction of the car's velocity vector is constantly changing. The velocity changes too. If you change your direction, you change your velocity and it affects the acceleration. Those are the two factors that can affect the vector, velocities vector. That's the speed and direction. Remember this value. Acceleration is change in velocity over time. The unit is in meters per second square. The change in velocity over the change in time. Final velocity minus initial velocity over final time minus initial time. Minus the initial time. Okay. So let's look at some other examples. A car is traveling along a straight highway for 20 meters per second. For 20 meters per second. The driver steps on his gas pedal and 3 seconds later the car speeds at 32 meters per second. Find the average acceleration. Like what we said before, the acceleration A is equals to change in velocity over change in time, which is equals to final velocity minus initial velocity over the change in time, that is change in time. And here the final velocity here is V1 is equals to 20 meters per second Then v final velocity is equals to 32 meters per second, and the time t is 3 seconds. So for us to find its acceleration, it will be 32 minus 20 over 3, which is equals to 12 over 3. And when we divide this, we have 4 meters per second square. That is the acceleration, 4 meters per second square. Okay, good. Let's look at another example. Spotting a police ahead. The driver of the car in the previous example slows from 32 meters per second to 20 meters per second in 2 seconds. Now, find the average acceleration. Like we mentioned, here we're looking for the acceleration is equals to change in velocity over change in time. That is Vf minus V1 over Vi times change in t. Now in this case, the driver was moving at 32 seconds but slowed down to 20. So the initial one, the initial velocity is going to be 32 meters per second, and the final velocity Vf is equals to 20 meters per second. Then the time taken, the t, is just 2 seconds. So for us to find the acceleration, it will be 20 minus 32 over 2, that is negative 12 over 2, which is equals to negative 6 meters per second square. So this is deceleration. The speed has reduced, so it has decelerated. The speed decreases. The speed of the car has decreased. So it's no longer accelerating to decrease. That's why it's having a negative sign. Okay? All right. Now we're talking about uniform acceleration motion and the big five. The simplest type of motion to analyze is motion in which the acceleration is constant, and it's called the uniform acceleration motion. It's the uniform acceleration motion. When the motion is, an object can move at a uniform acceleration. Another restriction that will make our analysis easier is to consider motion that takes place along a straight line, linear motion. In this case, there are only two possible directions of motion. It's either it goes positive or the negative direction. Most of the quantities we are dealing with is displacement, velocity, and acceleration. They are all vectors. So which means that they could include magnitude and a direction. With straight line motion, direction can be specified simply by attaching a positive or a negative sign. In a straight line motion, they have a positive or a negative sign. That's linear motion. Therefore, although we will often abandon the word bold letters to denote the vectors, quantities of displacement, velocity, acceleration, the fact that these quantities include direction will still be indicated as a positive or negative sign. So this uniform acceleration motion is just motion on acceleration on a straight line. On just a straight line, is linear, is on a straight line. And from this, we were able to get the different way to calculate these accelerations on the straight line. The fundamental quantities are positions of the x, that is the position is the x, that is this x is the position, that is this x. Velocity, these are velocities. Acceleration, these are the fundamental quantities. Acceleration is a change in velocity from the initial velocity. The initial velocity can be VO, it can be V1, to the final velocity. Final velocity can be V or VF. VF, final velocity. And the final motion takes place during some elapsed time travel. So we might have some time travel, that is this t. So these are the factors that we use, these are the variables in calculating accelerations, especially the uniform acceleration. You can have, as this is x is in position, the v's are the velocities, the a is the acceleration, the t is the time. So the main concern, the main factors about this big five right now is to us to be able to calculate our acceleration motion easily. Because there's some questions that might come up and we have all the equation, all the quantities stated. I want to pay attention to details. When we have a question and there is no acceleration in the question, like this, as if missing variable here, if a missing variable in the question is acceleration, and the question has final velocity, initial velocity, and has the time and has the position, then we know we're going to apply the big 5-1. Then if we have another question that the missing variable is position, well, and there's acceleration, there's time, and there's velocity, then we know we have to apply the big 5-2. That's this big 5 number, as big 5 number 2. Then when we have, maybe we ask to find a final velocity, the final velocity is the missing variable, but we have every other factor but the final velocity, then we consider applying this variable 3. Then when the initial velocity is a missing variable, we apply variable 4. Apply variable 4 if initial. Then I ask to find the time t. If the time is a missing variable, we apply variable 5. So all of these quantities are very vital to the uniform acceleration motion and the calculation of the big 5. So the big 5 is the calculation for the when acceleration is the missing variable, when position is a missing variable, or final velocity is a missing variable, or initial velocity as a missing variable, or the time as a missing variable. That is when we apply the big 5 calculations. Let's pick an example from here and see how we solve. An object with an initial velocity 4 meters per second, initial velocity, moves along a straight axis under constant acceleration. Acceleration is constant. 3 seconds later, we have our time. Its velocity is at 4 meters per second. How far did it travel during this time? So let's bring out all the factors that we have. We have our initial velocity is equals to 4 meters per second. Then the next one says acceleration is constant, so a is equals to 0. Because when you hear constant, you know it's 0 meters. 0 meters per second. What next? The time, we have time given is 3 seconds. Then the final velocity is 14 meters per second. So now we're looking for how far did we travel? That is how far. X is what we are looking for. So if you remember our big five, when we have all these variables, we're looking for the distance traveled. So we're going to apply the big five. So now x is equals to change x is equals to vt. That is velocity and time is equals to x. Right? That's the direction of the velocity. Change in velocity over time is equals to x. And for us to get that value, it will be equals to 1 over 2 brackets b, say, let's call it v, the initial velocity v1 plus f bracket t, because now we're going to calculate these vectors velocities together over t, which will be equals to 1 over 2 brackets. Initial velocity is what? 4. Then the final velocity is 14. Then the time is what? 3. So that will be 14, that is 18. That is 2. So that will be 1 over 2 bracket 18 times 3, which is equals to 9. 9 times 3, which is 27 meters. So for us to calculate this, we have to apply this formula. But how far did it travel? So it's talking about the distance travel. That's the total distance travel. So that's what we're adding the initial velocity plus final velocity times the time taken and half. This is how far does it travel. Because we applied, looking at the big five, a is the missing variable, and we're looking for the x. So we apply the big five number 1. That is, x is equals to half VO plus V times T. If A is missing variable, since A is constant, we apply this value to get the value for the x. Let's say how far does it travel, and we don't have an acceleration. But if there was an acceleration and there was no velocity, there's no initial or final velocity, we will have picked some other big five value. So when we're answering our question, we should always pay attention to the details, the missing variables, the question that asks, the how far that was asked, how far, that's if we're looking for the distance x, and the variables that we have available and the variables that are missing. Okay, so this is the end of today's class. So this is the end of today's video. Let me know if you have any question. If you have a question, you can put it in the comment section. And I'm still making more videos. And for more clarifications, I'm going to put the previous video link to this video so you can go back to the previous video of position, displacement, and distance time graph, so that I can recall how we were able to get how we explain the displacement and position. But the course is going to go through from the very beginning of position up until the end of kinematics. All right. If you have any question, you can put it in the comment section. Please don't forget to like, share, comment, and subscribe. And always remember to come in and watch our videos. When you subscribe, you get notifications once new videos have been published again on YouTube. I hope to see you again. I hope to see you in the next video. Thank you for always watching, and the more you share, like, the more you encourage me to keep uploading more videos. Okay? Have a good day and see you in the next video. Take care. Bye.